Okay, today I plan to tell about meaning of sample frequency and cumulative frequency, and how to distinguish between dichotomous ordinal categorical variables, how to identify appropriate numerical and graphical summaries for each variable type, how to construct a frequency distribution table for dichotomous categorical and ordinal variables, and how to differentiate between a histogram and a bar chart. Before starting a new topic, let's thinking back to the meaning of sample and what kind of measurement scales exist. Population is a collection of entities, usually people. A sample may be defined simply as a part of population by age, sex, nations, weight and height. In the given video, drumsticks are shown. All drumsticks are population, selected drumsticks are sample. For example, you can take official information about total number of breast cancer patients in Polda region. In this case, total number of breast cancer patients is population, selected number of patients who take part in your survey is sample size. Measurement scales. Flow chart illustrates type of data or measurement scales: nominal, ordinal, integral and ratio. If you forget a little bit about this information, follow to the first lecture named Introduction to Biostatistics. The frequency of a particular data value is the number of times the data value occurs. For example, if 4 students have a score of 80 in mathematics and then the score of 80 is said to have a frequency of 4, the frequency of a data value is often represented by f. For example, the marks awarded for an assignment set for a Year 8 class of 20 students were as follows. Let's present this information in a frequency table. To construct a frequency table, we should follow next steps. The first step is constructing a table with 2 columns. The first column shows what is being arranged in ascending order. The lowest mark is 4. Start from 4 in the first column. Secondly, count the number of marks for each data value and write it in the second column. In statistics, a frequency distribution is a table that displays the frequency of various outcomes in a sample. Each entry in the table contains the frequency or count of the occurrences or values within a particular group or interval, and in this way the table summarizes the distribution of values in the sample. Dichotomous variables are often summarized in frequency distribution table. In the given table, the first column of the frequency distribution table indicates the specific response options of dichotomous variable, yes and no. The second column contains the frequencies of individuals in each response category, the number of people who have hypertension and who don't. The third column contains the relative frequencies, which are computed by dividing the frequency in each response category by sample size, 2313 divided by 2532. The relative frequencies are often expressed as percentage by multiplying by 100 and are most often used to summarize dichotomous variables. In this sample, 65.5% of participants don't have hypertension and 34.5% have hypertension. A frequency distribution shows a summarized grouping of data divided into mutually exclusive classes and the number of occurrences in a class. It is a way of showing unorganized data to show results of an election, income of people for a certain region, sales of product within a certain period, student loan amounts of graduates, and so on. Some of the graphs that can be used with frequency distributions are histograms, line charts, bar charts, and pie charts. Frequency distributions are used for both qualitative and quantitative data. Dichotomous variables have 2 possible responses: yes, no, female, male. The given table displays the frequency distribution table for the variable gender. We also can illustrate bar chart to show relative frequency distribution of males and females. The next example is about treatment with antihypertensive medication. So one group got treatment under 34%, second group didn't, approximately 66%. Cumulative frequency is defined as the running total of frequencies. The frequency of an element in a set refers to how many of that element there are in the set. Cumulative frequency can also be defined as the sum of all previous frequencies up to the current point. The cumulative frequency is important when analyzing data, whereas the value of the cumulative frequency indicates the number of elements in the dataset that lie below in the current value. The cumulative frequency is also useful when representing data using diagrams like histograms. For instance, the set of data shows the ages of participants in a certain summer camp. Let's draw a cumulative frequency table for the data. The cumulative frequency at a certain point is found by adding the frequency at the present point to the cumulative frequency of the previous point. The cumulative frequency for the first data point is the same as its frequency since there is no cumulative frequency before it. A cumulative frequency graph, also known as an ogive, is a curve showing the cumulative frequency for a given set of data. The cumulative frequency is plotted on the y-axis against the data which is on the x-axis for an ungrouped data. When dealing with grouped data, the ogive is formed by plotting the cumulative frequency against the upper boundary of the class. An ogive is used to study the growth rate of the data as it shows the accumulation of frequency and hence its growth rate. Ordinal and categorical variables have more than two possible responses, but the response options are ordered and unordered respectively. Symptom severity is an example of an ordinal variable with possible responses of minimal, moderate, and severe. The National Heart, Lung and Blood Institute issues guidelines to classify blood pressure as normal, pre-hypertension, stage 1 hypertension, or stage 2 hypertension. The classification scheme is shown in the table and is based on specific levels of systolic blood pressure (SBP) and diastolic blood pressure (DPP). Participants are classified into the highest category as defined by the SBP and DPP. Blood pressure category is an ordinal variable. So the given table is the frequency distribution table for the ordinal blood pressure variable. The mutually exclusive and exhaustive categories are shown in the first column of the table. The frequencies or numbers of participants in each response category are shown in the second column, and the relative frequencies as percentage are shown in the third column. Notice that more than a third of the sample, 34.1%, has normal blood pressure. 41.1% are classified as pre-hypertension, 80.5% have stage 1 hypertension, and 6.3% have stage 2 hypertension. With ordinal variables, two additional columns are often displayed in the frequency distribution table, called the cumulative frequency and cumulative relative frequency. The cumulative frequencies in this example reflect the number of patients at the particular blood pressure level. For example, 2,658 patients have normal blood pressure or prehypertension. There are 3,311 patients with normal prehypertension or stage 1 hypertension. The cumulative frequencies are very useful for summarizing ordinal variables and indicate the percent of patients at a particular level. In this example, 75.2% of the patients are not classified as hypertensive because they have normal blood pressure or prehypertension. Notice that for the last highest blood pressure category, the cumulative frequency is equal to the sample size, 3,533, and the cumulative relative frequency is 100%. We can easily express data using histogram for ordinal variable. The given table shows the frequency distribution table for total cholesterol. Cholesterol is classified as desirable total cholesterol, borderline high total cholesterol, and high total cholesterol. Study shows that 51.6% of the patients are classified as having desirable total cholesterol level, and another 34.3% have borderline high total cholesterol. Using the cumulative relative frequencies, we can summarize the data as follows. 85.9% of patients have total cholesterol levels that are desirable or borderline high. The remaining 14.1% of patients are classified as having high cholesterol. Its relative frequency histogram for total cholesterol categories. The given table is a frequency distribution table for the ordinal body mass index variable. Both weight and height are measured directly, and BMI is computed as described previously. Study shows that 28% of the patients are classified as normal weight, 41.3% are classified as overweight, and 30.1% are classified as obese. Using the cumulative relative frequencies, almost 70% are underweight, normal weight, and overweight. This is equivalent to reporting that 70% of the sample isn't obese. Its relative frequency histogram for BMI categories. Okay, my lecture is over. I hope this information was useful for you. Thanks a lot for paying attention. Goodbye.